Okay, continue. We left off on part 7 on compound 1, and we continue as compound 2 clip, and we finish right here. First type of compound we call binary compound was 2 elements, right? So binary means 2 elements involved, right? 2 elements involved, and have multiple number of atoms. Could be just 1 to 1, could be 2 to 1, 2 to 3. Depends on the compound, right? Then within this binary compound, we have the first type, subtype is called ionic, and formed by cation and anion, right? Between the metal elements as cation and the non-metal elements as anion, right? And with a ionic compound, ionic bondings, right? It's very strong. Let's put here, very strong. Very strong what? Due to the opposite charged, right? Attraction between cation and anion. And as last time I put a crystallized structures and then say yes in crystalline structures, all right? And examples, right? And this is kind of ionic. And under ionic we have another small subgroups. One type binary compound, ionic, made from the element has only one fixed oxidation state, or you say charge, right? Was not any confusion for us to find the formula easier, because it always shows one type of plus charge or anion as non-metal negative charge. Now what are those? We already introduced the oxidation state long time ago. Now we are able to put it into use. Remember the first A. Number 8, 1A is the alkali metal family. Every element in the family has only one oxidation state as +1. So does the second family all have one oxidation state as +2. Remember that? And in the boron family, the third one almost like the first 2 all +3, and then going down may have +1. But it's already a little bit confused, right? A little more than 1. But these 2 are very, very clear. They only have one charge. Calcium always +2, right? Magnesium as well. And potassium always +1 because they belong to first family and the second family individually, right? But then you go to the other side of a non-metal, then those non-metal go by the oxidation state of the metal to form ionic compound. So their charge is not that important as long as we know the cation, their charge from the oxidation state belong to that particular family is fixed. Only one, then we have no confusion to pair with another non-metal atom with a certain number of atoms, right? So we are able to do that. So for instance, let's give you, so this first type out of ionic, we have a subtype, say I, right? And is what, right? The cation, the metal cation, have only one, right? One fixed oxidation state. Or charge, when you talk about ionic compound, right? Right, to form ionic compound with anions, with non-metal anions, with a fixed number of atoms from non-metals. Non-metal. So now this category has a huge number of compounds. We're able to list a few, and then since we are out of space, we have to erase this definition, right? And then put some example on top of the board. All right, here, so everybody has something to try to understand. Use them as example to understand what I'm talking about here. All right. So let's give some example, right? Let's see. Suppose, right? Example. Let's see. Example. If a compound is composed, right, with atoms from, right, 2A family, say calcium, right, with the atoms of let's see, 7A family non-metals, right? Non-metal elements, say chlorine, right? What would be the subscript for the symbol? Oh, that's not system. Symbols of the elements in the compound formula. Right? So we know. So the answer, right? Answer right here. Right? Now I need to take off this. Right? Just leave this pure cable still there for a moment. For the time being, all right. We may need to use it for this problem, or next problem we can use this part of it. So if we say the composed with atom from the number 2A family, which is the what? Alkaline earth metal, beryllium or magnesium, calcium. Here it says calcium. So it is what? Calcium has only possess plus 2 oxidation state, right, to form 2 plus charged cation, right? While 7A, which is a halogen family, and the chlorine's in the fluorine, and we already introduced oxidation state, either plus 7 or minus 1 normally. In this case, the cation is calcium. This gotta be a anion with negative charged status. So we have to pick the word minus 1. as oxidation state for chlorine. So while chlorine must be the anion, right? The anion. To possess -1 charged oxidation state, right? To be as a 1- charged anion. Now, in order to find a compound's neutral, we did not mention, we mentioned so many times, this time we did not mention, but we all know the compound molecule or atoms, they always neutral, right, to the outside. So it's neutral, and then in order to reach the neutral status for the compound, a single one unit of compound molecule, right? Or this time we don't call molecules, ionic compound we call formula unit, right? Formula unit, because the molecule can be separated in natural status, right? In nature, but not ionic compound. They stay in the crystalline structure, so strongly bonded because the opposite attraction, right? Opposite attraction from cation and anion, positive and negative, attract each other, right? So it's very difficult for them to spontaneously separate into gaseous phase atoms as monoatomic molecules. So they are going to be stick together in the crystalline structure, right? So we not call them molecules, we call them formula units, all right, formula units. Now, charge anion. So in order to achieve a neutral status, the +2, which is 1 calcium provide +2 charge, a 2+ charge, has to be balanced by 2-. But each one chlorine can only offer 1-, so we got to have what? We got to have 2 chlorine atoms combined with 1 calcium atom to be a compound neutral. So the answer would be, right? Answer would be CaCl2 subscript, not in front of the chlorine, because if in front that's 2 belong to the calcium, this time belong to the one in front of the subscript as chlorine subscript. So now, if we look into the calcium has a 2+ oxidation state in the formula, and then the chlorine has 1- what we call chloride in naming system IDE chloride, and the instead of chlorine and they use IDE ending, right? And then you have 2 of them, so you multiply by 2. That gives a what? 2-. The 2-, 2 positive, so it's 0, right? So these 2 come 0. So that's the formula. Right? That's the formula. Now this formula fit into any other member of the family 2A, which is alkaline earth metal, combined with any other member of the halogen family, which is the 7A group, right? They're all the same. So you are able to just duplicate by using this information. So we are able to say, okay, so we are able to easily write up many other compounds from these 2 families. They all belong to binary ionic compounds type 1, we call it type 1, and that has metal with fixed oxidation state, 1 oxidation state, no other choice, no confusion, and with different number of atoms to match the positive charge from the cation to make a neutral compound formula, right, with different number of atoms of non-metal. So we are able to say, so there are the following compounds, let me shorthand it, composed from 2A and 7A families. Right, so what are they? Let's see. Say beryllium. So the beryllium, right, and the fluoride will be changed F2. That is 1, right? 2 plus, 1 minus each, right? And you can have calcium, right? And fluoride F2. That's another, right? So you can have more, right? You can have more, right? You can have a bromide here, right? And you may have what? Magnesium bromide too, correct? And you may also have calcium, right? Bromide too, and extract, etc. You can continue forever, right? Because we understand this. Now that's type. Now then, that's the first type of ionic binary compound. The second type, let's see, second type, right? In the second type, the metal element has more than one oxidation state. Most of the time they come from the transition metal group, the B group. For instance here, let's give you a few of them, and those were not uncommon. Now the zinc has only one charge or one oxidation state, it's +2. And then the cadmium as well, +2. Now on this side, the copper has 2 oxidation states. One is +1, another is +2. So two of the charges, the oxidation state you have to deal with. Then here's the silver. It's only +1, and mercury and the gold underneath the cadmium and silver. These now the group 29, the number 29, number 30, and it's called what? It's called 1B and the 2B. Now we are not getting there yet, but we will give you the 1A, 2A right here. 1B, 2B. Those two has only 1 or 2 charge. The charge of +1 or +2. These two possibilities, just +1 and +2. So the A and the B for the first and second A, first, second B, they are similar. That's what 1A and 1B. Those elements, right? Now, but since they have, now this one has only 1. This one has only 1, right? 1. But this one has +1, +2. And this one has +1, +2, right? This one is +3. So let's see the second type, metal cation, right? Have more than one oxidation state. Right? Normal, usually, let's say, most of them in the B group, right, with transition metals. On the B group transition metals, right? And for instance, copper, you can have 1 plus or 1, 2 +2 and +1 +2, and the mercury also +1 and plus 2, right? One is called mercurous, one is called mercuric. All right, this cupric, cuprous. That's all use a Roman system. Copper 1 plus just Cu in the parentheses, Roman number I, and then Roman number double I 2, and that's the same thing here. So, but these two, right? At least these two. And silver got only 1, cadmium got only 2, but gold we're not going to get in there. So let's say these two, for instance, right? So what is the possibility for them to form compound, right? Form compound. That's the second type. So they may form more compound because they have different type of combination with anions. So let's see what we have. So examples, right? Examples, right? A compound, right, formed with, right, copper plus 1 and copper plus 2 with an anion from the nonmetal, right? Nonmetal group. That's nonmetal group. Let's pick up what nonmetal oxygen family. Oxygen family, right? Nonmetal oxygen family. Oxygen element, nonmetal oxygen, and chlorine. Right, chlorine. And what be their formula? Right? That's the example. So we have copper 1, plus 1, or copper 2, plus 2 oxidation state. Now the first one we're going to try to make a compound with oxygen, right? With oxygen. And then the second one we're going to make it was chlorine, right? So the oxygen is what? Oxygen in the case of 99% 9 of the chance make compound oxygen appear to be 2 minus charge anion or with a -2 status of the oxidation state. So oxygen, right, normally is 2 minus, right, 2 minus. And here the copper would be 1 plus, right, it's 1 plus. Then in order to match the charge to achieve the neutral status for the compound without any charge to the outside, how many atom of copper and how many atom of oxygen each in this integer number ratio we have to match to form a bond. Of course we need 2 copper atoms to produce plus 2 total number of oxidation state charge or states, right, value, and the match in the -2. So this gotta be Cu2O, right, Cu2O. Now we look back into the Cu right here is plus 1 charge, and you got 2 of them, so you multiply 2, that will be +2. Then this oxygen is -2, +2 -2 by itself. Of 1 oxygen atom is good enough to match the +2, so that could be 0, so that's neutral. So that is the first answer. The second answer, right, for the copper was 2 plus. Copper was 2 plus. And I want you to combine or compose a compound with chlorine. Now chlorine, we already said, when we give you the periodicity, all right, periodic trend of oxidation state for elements in the periodic table, we already stated the chlorine or the halogen family elements, the member of halogen family, they normally have the chance to form 2 common oxidation state of 2 charges. One is positive charge cation as positive 7. It happens, right? I'm going to show you. And then another one is minus 1. So in this case, copper is plus 2, right? So the second case, copper is plus 2, right? And the chlorine gotta be negative, so we're negative 1. And the chlorine is negative 1. So they seem to be, one is positive, one negative, opposite. They are able to form a ionic compound with opposite charge, opposite attraction, to form strong ionic bonding, and then form ionic compound. Binary also, only 2 elements, right? So, but are they able to achieve neutrality of this compound to the outside? No, 1 to 1 is not. 2 to 1 is possible, because plus 2 can be balanced by 2 chlorine atoms, each contributing minus 1. The value of oxidation state become 1 minus charge, 2 minus times 2 become 2 minus balance, 2 plus, you see. So this would be copper chloride was 2 subscript. If we go back looking to this 2 plus 2, this is minus 1, but you multiply 2 outside is minus 2. Plus 2 minus 2, they balance the neutrality, achieve the neutrality of the compound to the outside of this compound. This is called cupric, C-U-P-R-I-C, cupric, with higher oxidation state of cupric, and the chloride, right? This should be cuprous, the lower oxidation state, plus 1 oxide. Right? So that is the old naming system we call nomenclature. You're going to spend time on this and read that chapter and the sections on this textbook, and then we get used to those naming. All right, this is the 2 example. You can extend this kind of theory, the concept, into more compounds. Right? We could give you more, like mercury, mercurous, or mercuric. Right? So we're not going to get into that, but we're going to introduce another type, all right? So ionic, that's number 2. Ionic number 3. Ion number 3. Right? Polyatomic. Alright? Polyatomic, right? Polyatomic ions in compounds. Right, those compounds with polyatomic ions in it. Now, what are those difference between this and then the first 2 are binary? This is no longer binary, right? Polyatomic, so in other words, the compound have, right? It's contracted off a compound have more than 2 elements involved in their formula. Right? So no longer binary. No longer binary. Binary means 2. That's more than 2, right? So what is example? Right? Example. Right? Milk, magnesia. Magnesium hydroxide. There are 3. Magnesium, oxygen, hydrogen, and that will be times up, and then we continue, and then so part 8, compound number 3, right? It's milk, magnesium.